Take a deeply complex problem, like a tricky software bug. Ask a standard AI to solve it. It immediately looks for the shortest path, hitting a wall. Look at this diagram. On the left is that standard approach, a single shallow guess. But on the right is Anthropic's Claude Mythos. Instead of rushing an answer, Mythos maps out multiple logical steps and traces a complete thought process before making a conclusion. Consistent extended thinking requires a specific architecture. Today, we are going to construct a multi-layered reasoning prompt from scratch. We will test this build using a scenario most developers know well, a tricky multivariable software bug that has already dodged basic troubleshooting. Standard prompts fail here because they treat symptoms. By transitioning to a structured reasoning environment, we can isolate the root cause. Step 1 happens before you write a single line of text. You need to qualify the problem. Watch how we sort tasks here. Simple, linear queries go into the everyday bucket. Traditional models handle those efficiently. Use Mythos when your problem involves interconnected variables that require extended memory to track. Once you've qualified the problem, we start building. The first structural component is context engineering. We start with a clean interface. This context block drops in first. You feed the model your system architecture, background rules, and historical data, so it has a baseline to work from. The most common point of failure at this stage is vague language. If you tell the model the system is broken, it will lose focus during a long multi-stage operation. Instead of a messy paragraph, format the context as a structured list of rigid constraints and specific error codes. Setting this rigid baseline ensures the AI retains the exact scope of your problem. As it moves through multiple stages of reasoning, it maintains the rules you established at the start. With the memory layer locked in, we move from background data to active instructions. Notice the new section that snaps into place below the context. This is your reasoning requirements block. You use this to force the AI to execute sequential logic. For our software bun, we give it 3 specific commands. First, trace the data flow. Second, identify potential fail points. Third, propose 3 distinct solutions. To push the model further, we attach a synthesis block. This commands the AI to connect your problem to external domains. You must explicitly demand justifications for any connection it makes. This prevents the model from generating speculative or hallucinated links. Layering sequential logic with justified synthesis produces a rigorous analytical engine capable of novel discoveries. With the prompt fully built, it's time to run it and analyze the output. When the response generates, look for structural proof. You should see distinct sections where the model references your context, works through the logic chain, and synthesizes its findings. The output should explicitly reference the background rules established in Step 1, confirming the model is adhering to the defined problem space. Never accept that first answer blindly. Now you use a challenge prompt. Pick one assumption the AI made in its logical chain and tell it why it might be wrong. This forces the model to recalculate its path. That initial output is just a diagnostic draft. The real value of extended reasoning happens right here, when you actively pressure test the logic and force the model to refine its answer. This entire sequence scales far beyond troubleshooting software. What you see here is the complete multi-layered prompt template. 3 distinct color-coded blocks: context, reasoning, and synthesis. You can deploy this exact architecture to forecast strategic business outcomes or synthesize complex market research. But the model only reasons as well as you instruct it to. Your precision as the director dictates the results. Engineering an environment of deep memory and multi-step logic surfaces the high-level patterns necessary to solve critical problems.